This video covers 1.1.1 for OCR GCSE Computer Science. By the end of this video, you should be familiar with these topics. The CPU is often called the brain of the computer. Every program you run, browser or app, is just a list of instructions. The CPU's whole job is to fetch those instructions, work out what they mean, and carry them out. It does this billions of times per second. Note, a CPU is not exactly a computer. A computer is anything, takes an input, processes it, and gives output. This is the FDE cycle that repeats over and over while the computer is switched on. Let's see what happens at each stage. In the fetch stage, the next instruction is fetched or retrieved from memory. The CPU knows where to find it because the PC holds address of that instruction. Once fetched, PC is incremented or increases, so it's ready to point to whatever instruction comes next. In the decode stage, the instruction that's just been fetched gets interpreted by the control unit. Basically, the CPU is figuring out what this instruction actually means and what action it needs to trigger. Finally, in the execute stage, the instruction is actually carried out. That might mean a calculation is done, or data gets moved somewhere, or like an interaction with other components within the computer. Now, let's look at the main components inside the CPU that makes this cycle possible. The ALU is where all the maths and logic happens. Any calculation or operation is done here during the execute stage. The CU acts like the manager of the CPU. It coordinates the entire FDE cycle and directs the flow of data between the components. It uses the system clock to keep everything perfectly timed. Cache is a small amount of extremely fast memory, inside or very near the CPU. It stores instructions and data that get used often, so the CPU doesn't need to keep fetching them from the much slower main memory, hence faster processing. Registers are tiny storage locations built directly into the CPU. They're the fastest memory in the whole computer, but hold very small amount of data temporarily. The whole FDE process happens within something called von Neumann architecture, which is a model where both instructions and data live in the same memory. OCR listed these registers specifically, so let's go through them. The MAR stores an address, the address of memory location that's about to be read from or written to. Address register stores address. The MDR stores actual data as it's transferred to or from memory. Data register stores data. PC stores an address too, the address of the next instruction that's going to be fetched. We actually saw this one already, back in fetch stage. And finally, the accumulator stores results of calculations done by the ALU. It's where the answer to a calculation sits, ready to be used next. This is the information covered just summarized. Address is just location. It tells the CPU where something is, like a house number on a street. Data is the actual content, like what's actually inside that house. So, to round it all off, here's a nice recap page. Hopefully, these give you something to remember the content covered here. In case you want to quickly quiz yourself, answer these. Thanks for watching.